Let's talk about the future. Exploring tomorrow's challenges today with our experts. A podcast by Air Liquide.
Hello and welcome to Let's Talk About the Future, the Air Liquide podcast, where we bring you experts to talk us through the world-changing solutions of our time. In the studio today, we're delighted to welcome Nicolas Blasco, Senior Expert Technology Integration Electronics Activity, Air Liquide. Hello, Nicolas.
Hello, Vanessa.
When we think of high-tech, we think of computers, artificial intelligence, robots. But we don't necessarily think of the tiny components without which none of this would work. Semiconductor chips. Rana Foroha of the Financial Times, author Chris Miller, and Igor Mikulich Torreira of the Center for Security and Emerging Technologies at Georgetown University in the USA all agree.
It's hard to think of a component in any product, really, that's more ubiquitous and more essential than the semiconductor.
Today, almost any device with an on-off switch has one or often dozens or hundreds of semiconductors inside.
They power our cars, airplanes, trains, communications rely on them, factories, ordinary businesses and finance and banks. Money moves thanks to these chips.
This is true. Those components are everywhere.
Yes. Nicolas Blasco, for those of us who are far less knowledgeable than you, can you tell us briefly what this all-powerful element, the semiconductor, what's it all about? It is the same thing as a chip, isn't it?
Yes, so a chip and the semiconductor are two terms which are referring to the same thing with very subtle differences. A chip is a very small piece of silicon, typically 1 millimeter thick, and less than 1 square centimeter in surface. And it contains a very complex network of circuits which are made of semiconductor materials. And those components are used to run calculation or store information.
Okay. And a chip is indeed the same as a semiconductor.
So the chip is made of silicon, by the way, which is the most abundant material on Earth, and contains semiconductor materials.
Right. I see the nuance. And what is this semi? Why do we talk about semiconductor?
Semiconductor and semi refers to a fundamental property of those materials. They can be electrically insulating, like a piece of wood, or they can be electrically conductive, like a copper wire or a metallic wire, for instance, depending on how they are used. This is really important because this gives us access to the famous 0 and 1s that are the basis of all the modern computing. 0 when the material is in insulating position, and 1 when the material is in conductive position.
Okay, so semi because they conduct sort of half of the time. Now, it's those functions that you talk about that make all of our digital devices and applications work.
Exactly. Those components are literally acting like brains, which are operating all of our devices. They operate your smartphone, your car, your computer. They operate planes. They're basically used every time you have an electrical component. And those semiconductor devices are literally used everywhere in our modern life for communication, traveling, work, fundamental science discoveries in environmental science, medicines. Everything is using semiconductor devices today.
But although Air Liquide is, of course, a very large company and you produce essential molecules for industry and for society, such as oxygen, nitrogen, hydrogen, you don't produce semiconductors, do you?
Correct. Air Liquide doesn't produce semiconductors. However, the gases that we produce are used at every step of the semiconductors manufacturing. We produce gases like argon, helium, nitrogen, and oxygen that you referred to at the highest purity possible, which is necessary to create those networks I was referring to. Second, which is less known, we also develop new and innovative gases that are answering specific customer needs, such as improving the electrical performance, lowering the energy consumption, or decreasing the size of the semiconductor chips.
But just to come back to this, earlier you explained that a semiconductor or a chip is made of silicium or silicon. So it's not made of gas or other molecules.
That is correct. The really important point to understand is that a semiconductor chip is actually a very complex assembly of networks. It's like a 3D maze, if you want. And to produce that maze, you do need gas. And our gases are used at every step of the creation and the formation of those mazes. For instance, we produce gases which are used to etch, to make holes into the chip. And we also produce gases which are used to deposit materials into the holes with very high precision. And the more the chip becomes small, the smaller they get, the more complex the gases are to produce the chips.
Right. Yes. And you said chips are getting even smaller, but are they not very small already?
Indeed, they are already very small. The industry has been pushing the limits of what small means in the last 20 years. The latest generation chips typically have the smallest critical dimension of a few nanometers. A nanometer is very small. It's basically 1 million times smaller than a millimeter. Or to be more concrete, it's about 70,000 times smaller than your hair. Thanks to that, you can have many components in each chip. Today, a chip the size of a nail will contain tens of billions of components or transistors, which is more than human people on Earth.
Right. So it's clearly extremely technical. How long does it take to manufacture a chip?
Manufacturing a chip is a complex and long process which takes about 3 months and hundreds of steps. All those steps, such as deposition of materials, etching of the chip, lithography, are carried out in very clean fabs, which are huge and can cost tens of billions of dollars. And again, in an extremely clean environment.
You say a fab. What's a fab?
A fab is the name we use in the industry to designate a production facility where the chips are manufactured.
Okay. And are Air Liquide products involved in that whole process throughout those whole 3 months?
Yes, not only the Air Liquide products are used at every step, the entire process flow of the production, but also in some cases they are very unique and necessary. Some of the new gases and molecules we developed in the last 15 years have been massively adopted by the industry and are used today to produce every devices in the world. And we do co-develop those new materials and processes together with our customers and the technology leaders in the field.
Right. And so this really is a sort of race to innovate. How do you manage that pressure personally?
There is a great load of pressure. That is a fact. The industry is very dynamic, very fast, very innovative, and is constantly preparing the future. And for me, it's a great satisfaction to be part of that for several reasons. Number one, the innovation I contribute to and the projects I'm working on can be a transition to production within a few years, which is very rare. Second, there is a great satisfaction to be part of this technology revolution and see what happens behind the camera, behind the scene. See the competition between technology leaders, between equipment companies, between gases and material suppliers.
Okay. So the technical role of semiconductors in the ongoing digital revolution is clear to see. But the strategic aspect, literally on a global scale, really came to the fore during the COVID health crisis. Let's hear from Xavier Jaravel, Professor of Economics at the London School of Economics, talking about that situation in 2020.
Indeed, there was a shortage. There are two main reasons. On the supply side, the pandemic disrupted value chains, forced the shutdown of factories in Asia, and therefore inevitably there was an effect on supply. And at the same time, we had higher demand because we were increasingly working from home. We needed IT tools, and therefore more demand, less supply, rising prices. And the situation lasted, and the loss of semiconductors, even if it is a cost item that may seem low, often a few percent for a product like an automobile, but it can destabilize an entire value chain. And so we then had other factory shutdowns, automobile production, and so we can clearly see that there is a very, very major challenge, especially since in the next 10 years, semiconductors will be more and more important for the digital transition, the ecological transition. So that's why there is a lot of strategic thinking to be done on dependence and how to position ourselves in relation to Asia, where the foundries for the latest generation semiconductors are located.
Nicolas Blasco, has there been a change since the end of the health crisis? Is this dependence changing?
There is still an imbalance. Today, about 80% of the global production is located in Asia. And you can see a very strong effort from public authorities to bring more production in US and Europe. For instance, you may have heard about the American CHIP Act or the European CHIP Act, which are both putting tens of billions of dollars or euro of public incentive to localize more production in US and Europe. In addition to that, the market is expected to grow a lot. Basically, it's expected to go double within the next 5 years, from $500 billion today to about $1,000 billion in 5 years. So you will see more and more production facilities coming up and more effort from public authorities to bring those production facilities locally and reduce the dependency. The last thing I want to mention here is that the industry is extremely globalized. So even though production is mainly happening in Asia today, there are very unique and critical components which are produced in US and Europe.
And what about Air Liquide in all of this? What's the role of the company?
So we have anticipated the growth of the market, which, as I was saying, is going to double. So Air Liquide made very significant investment decisions in the last few years to prepare our production facilities to face the demand. We invested in new production plants for gases, but we also invested in new production plants for the advanced materials, which are unique and necessary for the new semiconductor generations.
So things clearly have really moved along. And what do you see on the horizon? How do you think the semiconductor industry will change in the coming years?
I would say two things. Number one, the miniaturization, reducing the size of the components, is going to continue. It has to be. It has to be to face the demand. In particular, the increase of demand in the memory space to store more information. And we expect in the next 10 to 15 years to really reach the physical limits of what can be done and to get closer and closer to the atomic level. So even below 1 nanometer. In addition to that, we expect to see, as we already started to, the rise of artificial intelligence and the need for massive calculation needs to face that demand. So more and more chips will be specifically made to face the artificial intelligence demand.
Actually, on that subject of artificial intelligence, can I just read you an extract from the magazine Fortune in November 2024? So I quote, NVIDIA boss Jensen Huang is starting to feel like Atlas with the weight of the world, or at least AI, bearing down squarely on his shoulders. The CEO and founder of the $2.9 trillion semiconductor giant spoke openly on the 11th of November 2024 about the tension he's feeling, offering a glimpse into the pressure he faces to crank up the supply of microchips capable of training the latest AI systems, like the successor to OpenAI's GPT-4. Now, that increase in demand couldn't be clearer. What about the supply side?
So on the supply side, what we expect to see is a stronger and stronger need for securing the supply chain. As was illustrated earlier with the COVID pandemic, the supply chain needs to be more resilient. And we see a lot, as I said, public investment to make the supply chain more resilient, more local, and reduce the dependency on other countries. So that is a very strong driver. The second strong driver is to work on chips which are more sustainable.
Yes, and in terms of sustainability, the environmental aspect is quite a challenge for the sector, isn't it? We hear a lot about the enormous consumption of energy and resources involved in the digital revolution, whether it's the extraction of raw materials, the production of components and devices, or the use of systems once they're in place, artificial intelligence, telecommunications, or simply the internet. In your opinion, Nicolas Blasco, is high-tech really compatible with the climate emergency?
I would say this is clearly a strong challenge for the industry. But one thing I would like to say first is that the energy transition cannot happen without the semiconductors. The semiconductors are essential, for instance, to produce energy with new ways, renewable energies, and connect them to the grid. Semiconductors are also essential to implement intelligent networks, intelligent grid, to optimize the energy consumption in cities. And semiconductors are also critical for the transition to electrical cars, just to name a few. So the semiconductors have to be there to enable the energy transition. That said, indeed, the sustainability of the chips is a very important topic. Number one, the chips must consume less energy, especially to face the exponential increase of demand that is expected from the artificial intelligence. And number two, the production of the chips themselves needs to be more environmental friendly with things that, such as lower water consumption, lower electrical consumption, and lower CO2 footprint. On that particular aspect, Air Liquide has a clear role to play.
Yes. And can you give us any real-world examples of that role Air Liquide is playing?
For instance, we continuously innovate on our gas production units to reduce the electrical consumption or to use renewable energy whenever possible to produce our gases. Second, we also innovate on the process gases themselves. And for instance, we developed in the last few years a new class of etching gas, which we call Enscribe, and which have a much lower global warming potential than their predecessors. And for instance, the use of such gases in 2023 allowed to avoid about 150,000 tons of CO2 equivalent.
So progress is clearly being made already. Well, look, Nicolas Blasco, thank you very much for shedding some light on a topic that is, in effect, fundamental for the entire world.
Thank you. I'm really happy if I could contribute to the understanding of this industry and the way the chips are made. I'm always, surprised how those devices can be pretty much like a black box for most people. And I'm really happy if I could contribute to remove a little bit of the black box aspect. Thank you.
Absolutely. Thank you. So, are you thinking, I want in? Do you want to work on semiconductors to make a difference to the future? Join Air Liquide. Click on the link in the podcast description and check out all the opportunities. And if you've learned as much as I have in this podcast, do give it a like and especially a share. But why stop there? We have experts sharing their insight into artificial intelligence, home healthcare, net zero carbon. And you'll find them all here where you found us today. And of course, subscribe so you don't miss the upcoming episodes. So let's talk about the future soon.
Let's talk about the future. Exploring tomorrow's challenges today with our experts. A podcast by Air Liquide.